If I begin with 115 milliliters of 8.9 molar solution of aluminum chloride, how many grams of precipitate will be formed? Well, okay, how many grams, so that's question mark, grams of the precipitate. So I need to figure out what is actually going to precipitate. If I look on my solubility chart, aluminum acetate. Does aluminum acetate precipitate, or will silver chloride precipitate? If you look it up, I think that you will find that this is the stuff that precipitates or precipitates. You can also use a down arrow to represent that. So I'm going to write AgCl on my dimensional analysis here. Okay, and I begin with 115 milliliters of, let's see, aluminum chloride, AlCl3. Now it told me what my molarity is, but actually that is a conversion factor. It tells me 8.9 moles of aluminum chloride for every 1 liter of aluminum chloride. Here's a problem. I have milliliters, so for every 1 liter of aluminum chloride, I have 1,000 milliliters of aluminum chloride. Okay, so I can use this one. I'm going to want milliliters to be on the bottom. 1,000 milliliters of aluminum chloride for every 1 liter of aluminum chloride. I do this so that the milliliters cancels the milliliters, leaving me in the units liters. Okay, so that's pretty cool. And if I take a look, I've already started with volume, and now I'm going to take molarity in order to get into mole count. Once I'm in mole count, then as I leave, I can figure out which way I want to go. But it's going to take molarity. So here's the molarity. I see that I have liters up here in the numerator, so I'm going to want liters down here in the denominator. Our aluminum chloride is 8.9 moles of aluminum chloride. And I do that so that liters of aluminum chloride cancels with liters of aluminum chloride. Alright, so now I'm in mole town. So how many moles of aluminum chloride and how many moles of silver chloride? So for every 1 mole of aluminum chloride, I get 3 moles of silver chloride. So let's see, I want 1 mole on the bottom, and that is of the material aluminum chloride, and 3 moles of silver chloride. And I do that so that the moles aluminum chloride cancels with the moles aluminum chloride. Alright, am I in the units I want? Nope, I'm pretty close. I'm in moles aluminum chloride. I want grams aluminum chloride. So if I go back and look at my quote-unquote train map, I'm in mole town right now. Eventually I want to know the mass. This is not a element, so I can't use atomic mass units, but I can figure out what the molecular mass of silver chloride is. if I calculate what the molecular mass of silver chloride is, I can use the atomic mass of silver with one atom and the atomic mass of chlorine with one atom. When I take the sum of that, I get 143.32 grams for every 1 mole of AgCl. So I have 143.32 grams of AgCl for every 1 mole of AgCl. Alright, I could use one more field goal, so I'll remove the 3 and I'll put up 4. And in this case, so now I want moles, so 1 mole AgCl for every 143.32 grams of AgCl. And in this case, the moles AgCl cancels with the moles AgCl. So when I do my math, I'm going to do 115 times 1 times 8.9 times 3 times 143.32. All of that over 1,000 times 1 times 1 times 1. When I simplify the top, I get the number 440.064.06. When I simplify the bottom, I get 1,000. And when I simplify that all together, I'm going to merc. That equals 440.06406 grams of AgCl. All right. And then, to apply significant figures, this has 3 sig figs, but this number has 2 sig figs. So my answer is going to have 2 sig figs. And so this 4 is significant. This 4 is significant. The 0 is not significant, but it plays an important role. It is a placeholder. I cannot put a decimal here. Grams of AgCl.